each of the operations that we've learned previously, we've also learned an opposite operation. We will not at this time learn the complete opposite of the operation that is exponentiation, because getting to the complete opposite is actually quite complicated. But we are going to learn part of the answer to that question, the square root. What is the square root? What is it that when I square it, I get this number? For example, when I ask, what is the square root of 9? And we express the square root this way. This symbol, this squiggly line, is called a radical. And it should be noted that it's different than the division bracket. We read this as the square root of 9. What question is this asking? When I say the square root of 9 is what, I mean, what is it that when I square it, I get 9? That is, what number times itself gives me 9? Now there's something I'd like you to notice in our multiplication table. In the multiplication table that I gave you, I have shaded certain numbers down the diagonal. Right, these are the numbers 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and 9 times 9. We see here that 3 times 3 is 9. That is, 3 squared is 9. And so the square root of 9 is 3. These numbers that we see down the diagonal here, these are a special kind of number called a perfect square. We call a whole number a perfect square if it's the result of squaring some whole number. We can only compute exactly the square root of a perfect square. And there really isn't a nice way to compute square roots in general. The easiest way is, if it's a small enough number, we check the multiplication table. If our number is not small enough to turn up in the multiplication table, we use trial and error to find its square root. For example, if we want to take the square root of 225, first we notice that 225 is too large to turn up in the multiplication table. And then we just try some numbers. We might say, well, what's 12 squared? 12 squared is 12 times 12. 2 times 2 is 4. 2 times 1 is 2. 1 times 2 is 2. 1 times 1 is 1. 12 squared is 144. Too small. What's 16 squared? 16 squared will be 16 times 16, of course. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. 1 times 6 is 6. 1 times 1 is 1. Just 6. 15, 2. 16 is too big. Let's try 15. 5 times 5 is 25. 5 times 1 is 5. 6, 7. 1 times 5 is 5. 1 times 1 is 1. 5, 12, 2. 15 squared is 225. Oh, that's it. The square root of 225 is 15. Notice, we are evaluating this square root. Just like we stop writing the second power after we actually square the number, we stop writing the square root after we actually take the square root. I'm going to give you one of these to try. Evaluate the square root of 49. The multiplication table will help. Pause the video and try this now. Looking in the multiplication table, we see that 49 is one of our shaded perfect squares. It is in fact 7 times 7. So since 49 is 7 squared, the square root of 49 is 7.